All right, I just wanted to start this chapter off with a video on Venn diagrams. Venn diagrams are such a huge, helpful tool when it comes to probability, and our book doesn't spend a lot of time on use of Venn diagrams, but it really is a really helpful tool in a lot of cases when it comes to probability. So I want to give you some of the basics here on how a Venn diagram works and how you can use it to organize the information. So a couple things right off the bat, just some of the notation that we got to talk about. But if you look at the Venn diagram that I drew here, there's basically four areas within a Venn diagram that you need to understand. And so the circle that you see here for A would just be the probability of some event, and then the circle for B is the probability of some other event. So 3 would be what they have in common, things like that. And so we usually use a U for a Venn diagram on the outside. That represents the universal set. That just means everything possibly related to this problem is in that rectangle. So usually when it comes to probability, all this would add up to 100% if we do things in terms of percents. A couple symbols that you need to be familiar with. So the one right here that looks like a kind of an N is most associated with the word and, or technically we call that the intersection. This is referring to whatever the events have in common, and so that's the main area that you're seeing right here is where they overlap or where they intersect. The U is for union. We usually associate that with the word or. So when we say something about event A or event B, that's the union of those two. This little prime notation, it's the same one that you see right here, represents the word not. And so I'll give you an example of that here in a minute, but usually when we refer to the complement of an event, you'll see that symbol right there. So within region 1, right here that you're seeing, so here would be the notation for that. So if A or B, so you'll see right here, A or B are areas 2, 3, and 4. Right, that's all the information that is in either A or B. So area 1 are simply the things that are not in A or B, is the best way to see that. Area 2 is what we would call A only. So it's the things that are in event A. So remember, this entire circle is all of event A, right? So, but these numbers right here would be the things that are in A, but not in event B. And so here's kind of the way that you'd see that with notation, the things that are in A and not B. To get it, you would take all of A and subtract out whatever A and B have in common. So in this case, it would be all this whole area right here minus this area of intersection. And that would give me the things that are in event A only. A and B is that middle piece, so that's number 3. That's the things they have in common. B only it's just like this one, but on the other side. So B only is region 4. It's the things that are in B, but not in common with event A. So to find it, if I know all of B and I subtract out what they have in common, that leaves me with the B only number that you see right here. So I'm going to show you one example out of an old math studies book. So if you're looking at this one here, you can just kind of pause this video if you need to see what's going on up top. But this is basically what I just explained to you. So let me go down to an example with some real numbers here. So if you look at this setup that you see on this one, so they're giving us the universal set, which means again that everything in this whole rectangle should add up to 50 for this problem. So the number of elements in event A would be 32. So remember, that is everything in event A. So that's everything in this entire circle should add up to 32. They tell us that B is 25. So everything in circle B should add up to 25. And they tell us that A and B is 11. So that's what they have in common. When you go to fill out these numbers, the best place to start on a Venn diagram is in the middle and then work your way out. So I would start with what they have in common. So I see the 11 right there. Next would be to subtract my way out. So if all of A is 32, that means this entire circle needs to add up to 32. So if I subtract out that middle piece, I'm left with 21 numbers right here for A only. Same thing on the other side. All of B was 25. So if I subtract out the 11 that I've already used, I'm left with 14 remaining in the B only section. Notice on this one, the universal set was 50. So if I add 21 plus 11 plus 14 together, I only get 46, which must mean the other 4 are out here that are not a part of A or B. And so that's just one way to look at it with some real numbers. Let me go back to my drawing here for a minute and show you one example that we could use this for in probability. There's more to this, but I'm just trying to give you some level of introduction to Venn diagrams since you probably haven't worked with these before, or maybe you have, but maybe you need a refresher. But anyway, so in this particular problem, let's just say you went to a classroom and surveyed all the students, and you asked how many people play football, how many people play baseball, and you calculated all the numbers, and here's what you found. You found that 50% of the students play football, 60% of the students play baseball, and 20% of the students do both sports. If we were to fill out a Venn diagram for this, remember to start in the middle. So 20% do both. So 20% play football and baseball. For football, so here's my football circle right here. If 50% played football, keep in mind that we've already accounted for 0.2 of those students. So the remaining 0.3 would be those who play football only. For baseball, again, you got the 0.6. So if I subtract out the 0.2 that I've already accounted for, I have 0.4 remaining for who play baseball only and don't play both sports. If you add those up, you'll see those add up to 0.9 or 90% of the students, which must mean that the remaining 10% of students don't play either sport. Once you have that diagram filled out, though, answering these questions becomes really easy now that I have a good diagram to work with. So for this part where they say, okay, well, what's the probability that a student plays football or baseball? Well, if you remember what I showed back up top, the or statement would be any student within any of this area here. They play football or baseball, so it could be this 30% or that 20% or that 40%. So if I simply add those together, I can see that 90% of the students play football or baseball. Play baseball and not football. So that's what we call the baseball only group, or the B only. So the kids right here are the ones who do baseball but do not participate in football. So that would be the 0.4 that you see on that one. Football or baseball, so this is the not, so remember this is what we call a complement of this one right here. So if 90% play football or baseball, well, if we say not football or baseball, right, that was the remaining 10% that we see right here. So that's where we see that one. For ones who play only one sport, again, this is easy to figure out now that I have a good diagram. So this 30% plays only football. That 40% plays only baseball. So if I add those together, I can see that 70% of those students play only one sport. And not two sports, not no sports. Right, I got the 0.7 from there and there. So that's just some introduction to Venn diagrams. I still encourage you to, even as we move forward, if you want to come in and get more help with Venn diagrams, or even YouTube a couple videos on Venn diagrams and probability, it's really a helpful tool for some of the things that we'll be doing in this class. So I hope this helps. Good luck for the rest of the chapter.